Going back to circles, specifically looking at a segment, okay, and sectors. We've done a little bit of sectors before, but not segments. First of all, as a reminder, area of a circle, pi times radius, okay? And that is distinct from, again, the circumference, which is 2 times pi times r. All right, so here we go, area of a sector. How do we get that? Well, this is not the full area, right? This is just part of the area. So what part of the area is that? Well, we need to know what is the measure of that angle, the area of that sector. So once we know that, we put that over 360, whatever that is, times pi times radius squared. All right, so make sure, again, that is in your notes. Theorem, they call it 108, but Theorem 108 then just says, so then to find this, you do that. Okay, hardly a theorem, more like a formula. But anyways, here we have a problem, 12 meters, 60 degrees. So I say 60 over 360. Hopefully you can do some quick math there and reduce that to 1/6. Again, times pi, times the radius squared, which in this case is 12 squared. Reminder, you can do some canceling here. So this 6 cancels one of those 6's. So I still have a 12. I still have a 2 left over from the 12 and the 6 times pi. So the answer would be 24 pi units squared. Or no, meters squared. Okay. All right, so that is the area of the sector that's here. Now, what is a segment? Kind of weird to speak about a segment of a circle. But a segment of a circle is, you take a chord and then shade in one side, whatever side that is. This is kind of tricky to do because, first of all, it's not a rectangle, it's not a triangle, it's not like from the center of the circle, but that is the idea here, is you want to create a angle. And now notice I have a sector, right? That, and then I have a triangle. Voila. So I'm going to find the area of the sector and subtract the area of the triangle. All right. Again, how do we do this? Well, the area of the sector is a percentage times pi r squared, right? Minus the area of the circle, which is 1/2 base times height. All right. That is the formula that you should use, though I think, you know, this is almost as useful because that's where we get it from. So here we have a case of, we know our radius, z to x is the radius, and we know that the angle is 90 degrees. So we've got 1/4. 1/4, again, times a radius of 8 squared times pi, minus, now subtract out the area of the triangle. Notice we have a 90-degree relationship here. Very nice that that is that way, because now all I say, okay, 1/2 times 8 times 8. So I think this gives me 16 pi, if you do that math right, 64 divided by 4, minus, and then in this case we have 32. So it is this units squared. If I were to approximate it out, 16 pi is 50, 32 is that. So roughly my area to the nearest thousandths is 18.265. All right, well, tomorrow we look at dimension.